officially recording here. Hi, David. Are you at the actual conference right now?
I am. I just got out of a breakfast that the USGIF people hosted for
Okay, all right.
students from HBCUs and minority serving institutions.
Oh, cool. All right. Well, we don't want to, we're recording this, so if you feel the need to go somewhere, because today we're going to talk about data wrangling, some of the things with my specialty or whatever. But I didn't accidentally leave my email open here. I got an email here from a woman named Amy Ratliff. She's a city engineer up at the city of Oxford. We previously had some internships with a couple of students. One's name is Troy, another one's name is Antoniquan Johnson. Does anyone recognize that name? Tony Johnson. He's actually one of our adjuncts now. So we hired him to be an adjunct. But when he was a master's student here, they did an internship where they did asset collection for the city of Oxford. I don't know how I hooked up with Amy. I think she emailed me or I emailed her or something like that. And she was looking for students to provide internships for asset management because basically she's the city engineer. City of Oxford, it's up in, what county is that gonna be? In Person County, Vance County? Vance County, they don't have the resources for a GIS person, so the city engineer basically does that. They do everything. And so I know she was an engineer back in the day. She went to Virginia Tech, probably, I'm not gonna say probably, before GIS was invented. I know how old she is. And so she's kind of caught on the GIS bug, and we did some asset management with sidewalks, road conditions, other things like that as part of their GIS. And you can see some of the needs that they have here is that they're doing field collection, creating layers, inputting data, combination of phone and Google Maps, compare notes, fire hydrants, things like that. Because a lot of times the stuff we do in geostats and maybe a little bit of data science, we're going to talk about some of the data science stuff today. It's fun and it's sexy. You make the reds and the blues and all that other stuff, but it really doesn't mimic reality. Most of the time, you're going to be collecting data. And so on Thursday, we're going to be creating surveys and field maps using our phone. Here's our phone right here. And then actually, we're going to try to look it up also using a nice high quality GPS unit. And so that Geo phone app, this is about $3,000 here, but we got this GPS right here and maybe see how well it compares. But I think you're supposed to screw something in at the end. So, you know, you did some surveying, right, Andy?
Yeah.
So can I screw in like a broom handle or something? Or
That is special pool.
a special pole or something like that. I don't know where the pole is. So whoever told me to buy it, I don't have the special pole. So if we see a special pole laying around, we should probably get it.
But it works with that.
Yeah, it works without it. All right, Andy said it, so I could just walk around with one of these things here. I probably shouldn't juggle it or anything like that. But walk around with these for asset management, so like manhole covers, fire hydrants, other things that they want to collect. They want to keep information about the city. The city engineer would want to keep information about to do that. So things with parks and greenways as they kind of evolve and take advantage and utilize some of the green spaces, utilize some of the green space as well. But she's got some internship opportunities here for asset management. So if someone, I'm looking at Ahmed right here, is interested in something like this, maybe after class is done and you see some synergies or time attached to these, let me know. I can kind of connect you, and then me and her can kind of fund you because she's paid students in the past. There's a nice lady up in Person County named Sally Vaughn, who's been very generous to NCCU students. And they have 2 GIS people for the whole county. So they do like zoning, they do parcels, they do 911, they do E911, anything that you can think of related to a map. That's what she does. And to me, that I find that attractive because I'm kind of a jack of all trades. So I don't want to be doing any one thing all the time. I want to do like lots of different lots of different things here. But there's people here. We have a student. He sat in the back. He was a history major, and he works for Durham parcel mapping, and that's all he does is Durham parcel mapping or utility mapping or whatever. And so kind of pick your poison or whatever you like to do. You know, you could be the expert at every one thing, or you could be like me and pretend to know a little bit about, you know, pretty much everything. But today, what we're going to do is we're going to focus on some of the stuff that I like, that I'm good at, and that kind of bring me back to my roots. And this class especially, some of the technologies I'm not that good at with the, you know, GPS. We've got a surveyor here, someone with a surveying background here, so they can probably speak to this a lot better than me. But our ultimate goal is to go and make GIS data, because a lot of times when we do a project, whether we're looking at food deserts, carbon sequestration, you know, climate, chicken processing plants, COVID, my first question, there's one over here of SIDS deaths. So sudden infant death syndrome, when kids die, like literally just die like before the age of 1. You know, it happens. My wife had a cousin who was real young and just never went to bed, never woke up. And it actually impacts males a lot more than females, believe it or not. And so my first question with all of these is going to be, where do you get the data? Where are we going to get the data for SIDS deaths, for AIDS mortality, for the food environment, carbon sequestration, you know, because we want topics and projects that are kind of within scope. And this scope can be the actual topic and the actual scale. In my data science class, I joked about this student who wanted to solve the water crisis in Northern Africa. They wanted to like build this inland sea in like Morocco or something, and it's not at a scale that's going to be appropriate. You know, it's just not at a scale that's going to be appropriate. And I wish they had an advisor, because I wasn't their advisor. I wish they had an advisor that says, we're not doing that. We're going to do this. And so your advisor, you know, will hopefully do that. But at the end of the day, you know, if you go to a big department like University of Georgia or UNCG or any of these other places, you know what they're going to say when you propose a project like that? Sure, go ahead. I don't care. You can keep paying, you know, keep paying to stay here until you figure it out, until you you know, nourish all of Northern Africa with water. I don't care. You just keep paying until you do that. And so at the end of the day, you're going to be the one. You guys aren't laughing. You guys already heard me talk about this, didn't you? I was just so, you know, Dr. McGinn, he had just started here when that student was here, and he was just amazed at like, it was just like, and the student never finished. That's the sad thing. You know, they got straight A's and they stayed here for like a year and a half trying to do this project. That's all they did. And then they had some health issues and they never finished, you know. And we want you to do, you know, projects that are going to be meaningful, especially with the mission of NCCU, where we really want to impact and create tangible change in our communities. I think something focused around the neighborhood or the county or the state, which can facilitate data-driven decision-making and change, would be really good. So, you know, asset management for, you know, City of Oxford, you know, what are they going to do with it? Because you can see right here, she uses the word decision-making. This isn't stuff. These aren't things that are my keywords that I like to use. This is something that Amy, who works out in the field, does. So this is a project here. So I'm kind of looking at Ahmed here. And so if they're, you know, summer projects, fall projects, when are you looking to graduate? December. So, hey, this might be a nice internship project that we can give you credits for and throw a little money your way. And, you know, you can work with her with Google Earth and maybe going up there once a week and seeing what she wants and actually seeing, what they do. You know, maybe they're hiring a, you know, second engineer or, you know, looking for recommendations or something like that. And working with Amy previously in our previous relationship, you know, these students went off to do bigger and better things. So today we're going to talk about creating data from standalone tables. I want to minimize this. So creating data from standalone tables. Tomorrow, we are going to bust out the drone. So yeah, we're gonna get the drone here. I'll probably let Ahmed lead that because he flew the drone a lot this summer, or this semester here. We got a couple different types of software. We got Drone to Map. We got a Web ODM. These are just different ways that we can post-process data. You know, basically, we go and take pictures, we feed it into the software, you tell it what you want, and it'll give you DEMs. It won't give you LiDAR quality DEMs, but it'll give you some nice, DEMs, DSMs, digital surface models. Typically, the drone can't differentiate between the surface and the elevation, where that other types of applications can. But we're going to take a tutorial called Drone to Map Basics, and then we're going to put all of our captured imagery. We're going to just go out and fly over there. We're going to take some cool videos, but we're also going to collect some imagery at different elevations. I like to take them at nadir because I'm a GIS person, so I like to take them straight down. But when you start to create some of the 3D imagery, you do want to create the different angles, and then we played with some of the parameters, like where I'm like running along and it's like following me. That was pretty cool. I look like a real clumsy runner, even though I am a runner. But it could follow you along. So some of the aesthetic things that you can do. You can create a point of view or a point of interest, so it just flies around. So the drone that we have actually isn't all that. I don't want to use the word good. It's like $2,500. It's good.
Amazon is seeing models.
Okay, the Mavic 2?
Yeah,
Okay. But we have some it's a good drone, but there's some things with the planning, and then I got to do it on my phone and everything, which is kind of a pain in the neck where I set up everything instead of me setting in pre-flight plans and things like that. And so we're looking at a software called SiteScan. Have you heard of that? SiteScan. That's another software package that we can add to. But I'm trying to get an educational license, and they want to charge me $2,500 a year. So yeah.
Later, maybe sometime, maybe we can find time, maybe next week or maybe this fall. How big potentially point of interest? We've used models where it's been relatively smaller or like a smaller scale, like we did earlier this year of the parking deck. Can that whole parking deck potentially be a point of interest?
No, just one. But one of the things we can do is set up a path.
There's a path around.
So we were at a drone workshop last week. Remember, I sent it out, but drone workshop where they preload flights. They preload flights that go all around, so it has an appropriate coverage, 50 to 70% coverage, and overlap with each of the images at certain elevations. And so we were kind of specking out some drones that had multispectral, and then did some kind of LiDAR stuff, which is going to be using light instead of radio waves, but they use it mainly for what I know, elevation stuff, where you're looking at probably hundreds of dots per square inch, right?
Yeah.
Hundreds of dots per square inch instead of one dot per square inch, which this drone might be able to do. So that's what we're doing tomorrow. And then Thursday, we are going to be using GPS. So we're going to create surveys. We want to look at telephone poles. We want to look at anything. What's the information that we're going to want to collect about it? So we'll tie in a little bit with what we're doing today. And then at 11 o'clock on Thursday there, and I'll send out information for it, there's going to be a talk in the department. I don't know why they scheduled it for this week, but we're going to go see a talk on meteorites at 11. So we'll finish everything up and go to our talk because that's what I was told that we're going to do. So nothing wrong with that. It looks pretty interesting. We did have a student here who was interested in, who did some work in meteorites, and I think they're at Ohio State or Virginia Tech or something like that, doing that. And they were good. They were into it. So today, we're going to talk about turning standalone tables into maps. I'll kind of give my spiel here. We'll open up the project, and we'll open up some different types of tabular data that we can turn into maps. I was kind of showing you my running course yesterday where I ran, and then I downloaded it into a big GPX file. It just looks like some tagged file format. It looks like some tagged file format here that can be consumed by our GIS software and turn into points, or in this case, points, lines, polygons, in my case, points. So you can look at my actual running course that I did. And so if I think of it, I don't know if I'm going running tomorrow or Thursday. I'm hoping to go running early tomorrow. We can load that thing in and see what it looks like and see the different types of information that's captured by it. Because I like using this word geopotential, geopotential data. So today we're going to talk about attribute data. Some of these things we're kind of rehashing what we've talked about before, but I swear. Oh, I need to pull this thing out. Sorry. And we'll get it going here. So attribute data and the conversion of tabular data to GIS data. And so when we look at a GIS, and this is kind of rehashing, when we look at the left of our GIS software, that's called the table of contents. In the left, we've got layers, themes, feature classes, shapefiles. Back in the day, we used to call them coverages. They all, to me, mean the same thing. And down at the bottom, we'll see standalone tables. And we're going to focus on those today. We'll also start to see things like TINs and network data sets, these really complex features used to store geographic data that are above and beyond our points, lines, and polygons. But individual instances within each feature class are called features, and they're attached to records within the attribute table. And the thing about a GIS is that it links standalone tables. Okay, each of the records in a standalone table with a feature on the map that can be measured with geographic coordinates and real world coordinates. And so if we have 100 counties, the attribute table is going to have 100 records. And they're stored using attributes. So what's the information that you want to store about county? Pop 2000, Pop 2013, pop change, median age, all the data taken from census. Some of the data that we looked at yesterday for those zip codes, I started getting median household income, percent Democrat, percent Republican, percent unaffiliated, taken from some of the work that Dr. McGinn and I were doing before. But if we're looking at information on a sex offender, what's the information? What's the type of information that people are going to want to look at or are going to be required by law about a sex offender? So when we go out and collect data, what are all the things that you're going to want to select? And when I work with the military, I worked with a GPS unit a lot like this, where we go and collect different firing points. So I'd stand here and collect the firing point, and then go over here and go to the firing point, and go to here and go to the firing point. And we had to say, hey, what range number we were looking at, because when I go back home and fly home from Puerto Rico or Kentucky or wherever I was, what are the 3 words that I never wanted to tell my boss? I don't know. When they said, what range was this? Or what date did you collect this? Is this the left or the right firing point? They don't want to hear, I don't know. And so I have my little notebook here where I was taking notes here. But these days, we got these Survey 1, 2, 3. We have these things called Quick Capture or whatever. We've got these phone apps right here that we can take pictures. Hey, I'm at range number 2 right here that I can attach everything to. And so we've got this overabundance of information that we can collect that we just need to put in some sort of formalized format there. And so we've got tons and tons of attributes out there. Now you go and decide the attributes, but when I work with the military, we work with something called SDS-FIE, Spatial Data Structures for Facilities, Infrastructure, Environment, meaning every military installation in the world or in the United States uses roads. They call it road underscore centerline. Okay, range underscore polygon. So that don't send me your streets, don't send me your roads, don't send me your highways. Send me your road underscore centerline. And they all have the same attributes. And some of those attributes, they all have the same domain tables. So you only have 5 possible roads. You got interstate, primary, secondary, tertiary, or unimproved. Those are the only 5 possibilities. So there's no like state roads and local roads and highways, and they don't have any of that stuff there. And so you need to categorize those. And then we developed SOPs that said, okay, these are the ones that you need populated, because you may have 100 different attributes, but I'm not populating 100 attributes. So we'd populate, 14 or 16 attributes attached to those. But in order for these to line up, we need to make sure we've got data so they can be overlaid and projected together, so that we've got the counties that line up with the states, that line up with the cities, that line up with the zip codes, that line up nicely and neatly. So when we look at something like a sex offender here, this is up my way here. Sex offender, what's the information that we want about a sex offender? Okay, versus a parcel. Because when we look at data, this is how data looks. Okay, I use this word geopotential, and I'm trying to, market or trademark, this idea here, but most of the data that we look at comes in this format. The day and age of having these hubs where we can download data or connect to services, this is only like the last 10 years. When I started in GIS in 25 years ago, like this is what data looked like here. All right, I got a latitude and a longitude, because someone had to collect this at some point in time. So you think about, and we start to appreciate the time and effort it takes to go through and collect and create these data, because at some point in time, someone had to create it from scratch. And we had a project in our crime mapping class where I gave you the latest and greatest buildings outline for NCCU, and it wasn't correct. You had to go and create it from the latest data. And I bet you in 5 weeks or by the end of the summer, you're going to have to correct it again, because of we're getting rid of Baines and we're building new things. And we got that new thing at I don't know what it is, that learning center at the corner of Lawson and Fayetteville Street. So we're going to have to go and create it. It's living and breathing thing. So the second a map or a paper map gets printed out, it becomes immediately obsolete. Even though I love these things, I love looking at these things, but these things are obsolete. So we've got these data sitting here, and some of these are sitting in services, live services, but this is what data looks like. When we go and download tables from the census, and Barron is down at in Orlando, but we were working with census data, because what he was looking at was median household income of all the census tracts near the what's it called, CAT, the railway down in Charlotte. Yeah, the CAT system down in Charlotte. And so we were looking at, hey, how has the income been impacted for the areas near it versus further away? Just in Charlotte as opposed to Mecklenburg County. When we download the data, this is what the data looks like. We've got to connect it to points, lines, and polygons, because we're looking at 2000 versus 2010 versus 2020. And guess what? The number of census tracts in 2000 is different than 2010 and is different than 2020. And so not only do you have to make this data line up spatially, you got to make sure it's updated. And then we can derive things like high school graduation rates for different counties. We don't know where in Bertie County or what high schools we're looking at here. We just know for the entire county, that's the graduation rate, and we can extract these. And then we can look at some of these big things. And I think we looked at this for geostats, but also not only geostats, but maybe a little bit in data science, because when you go and like download the kind of base data for North Carolina State Demographer or some of these other portals or whatever, hey, we're looking at Alamance County for the year 2000. We've got male, female, but we've got 2000, 2001, 2002, age 0, age 1, age 2. Think about how many records we're looking at right here. We're looking at thousands of records to get these. And so the book uses the idea of standalone tables versus attribute tables. So in our ArcGIS Pro, in our table of contents on the left, you'll see standalone tables. So when we open up the project today, you'll see some standalone tables that I used a little black plus sign and I added them to. In our crime analysis class, and I know in data science class, we kind of worked with these standalone tables and figured out how we can bring these into GIS. I like this thing here. I don't remember making this, but this is a pretty nice comparison between our attribute tables and our standalone table, where that an attribute table is connected to typically your vector data model. Your raster data model is going to have kind of a pseudo attribute table, but it's largely going to be a frequency table, because imagine having a attribute table of all the different elevations with like 6-digit precision. For a raster, you're having like millions of records in that attribute table. So it's got a frequency table that's typically used with categorical data or less granular data, but it has a one-to-one relationship between records. And typically when we look at an attribute table, it's going to have an object ID that serves as that link between the record and the actual object or feature that we have. And also we'll have extra columns to account for geometry that you can't play with, or you better not play with, because if you mess it up, really bad things will happen. Our standalone tables are data that you download from the internet into various formats. There's tons of formats out there. We just got to make sure that ArcGIS Pro likes those. To me, ArcGIS Pro really doesn't like XLS or XLSX formats, just because it's got the multiple tabs. When you open up Excel, it's got like the multiple tabs. So I'm looking at Tim's file. They're all called Tim's file, but it's got sheet 1, sheet 2, sheet 3. And if you ever try to bring that into GIS, they name those sheets using a $sign. And what do you know about using like $signs and asterisks and parentheses in file names? That's not good. And so typically in Excel, I'll store something as a CSV file, which stands for comma separated files. But we've been to the, in data science class, we went to the vital statistics database, and they store everything as .tabs. Was it .tab, I think? Yeah, .tab or .data. They don't contain object IDs. They're stored as aspatial data, not linked to points, lines, and polygons. And so what our goal is today is we want to link it to points, lines, and polygons. We want to create points, lines, and polygons from these. And so we need to run additional operations such as geocoding, tabular join, summarizes, adding XY data. In data science class, we focus a lot on this summarize, where we have a list of every single person in the state of North Carolina who died. That's a big list, like 120,000 people, because we want to figure out what they died of. And so we can look at, in our class, we looked at gunshot wounds. And so we had a student who was a former police officer look at gunshot wounds. So we cleared out all the gunshot wounds using one of the 60 different attributes. And then we ran something called a summarize, which counted the number of times each of those zip codes appeared. So we could just get a frequency table. So it said 27425. 16, 27707, 277073, or whatever. We can map those using a simple core plus map. Especially, we have zip codes. Go to last class, we already have every single zip code in the state of North Carolina ready to go. And that typically doesn't change, even though your census tracts and your block groups are going to change. They're going to be increasing more and more. What I like to do is I always export my standalone table from this native format to a database. Okay, it's just stored as a table within our working database. You know, week, day 1, day 2, day 3 data, or whatever we're working with. Because when we look at these, this is kind of what we look at right here. We see the one-to-one relationship. So when I highlight Alamance, Allegheny County right here, you can see what they're highlighted in the table or highlighted on the map. And I think this is pretty self-explanatory, and I'm kind of reinforcing some of the things for people who haven't done this in a while. Because when we do this in a standalone table, it does not work that way here. But these are examples of standalone tables, because my big question with anything is, you know, when someone says, I want to map gunshot, you know, the gunshot deaths or shotgun, you know, gun deaths in North Carolina, where are you going to get the data from? That's the biggest question. Because at some point in time, guess what? You're going to be the one who has to go create it, you know? And if you're doing like a really high quality master's thesis, or you're going to be doing your PhD, you might be the one out creating data. You know, with gunshot wounds, we're extracting it from existing databases, probably doing a little data validation on the way. But you're extracting it from existing large databases because we've got this plethora of data just sitting out there, figuring out, what we want to do with it. And I always say there's this arms race between data and memory, the same thing between this data that's always being created and what we can do to it and all the processing here. So we can see things here like infant mortality rates here. So we can look at infant mortality rates. I have a county, Alamance, Alexander, Allegheny. I have infant deaths, non-Hispanic deaths, non-Hispanic African-American deaths, non-Hispanic American Indian deaths. And geostats, we kind of talk about some of the challenges of working with like small number problems and things like that. But cancer deaths, this is a PDF. Can you save a PDF as Excel? I'm sure there's a way to. Just go to the Google machine, convert PDF to Excel. We can bring this into an Excel. And then we might have to get rid of this junk up here. There might be an extra column right here or extra row right here, but we can go get rid of this and make it line up. That's the biggest portion of any project is data prep. Putting, this infant mortality, we had to put together like years and years of data together. And when we did this previously in data science class in 2013, 2014, they changed their schema. And so that instead of calling it like B county, B_CNT, they called it BTH_CNTY. Like they changed the names of the actual attributes. I don't know why, maybe to align with some type of existing standard. And so you gotta put all those, make all those things line up. And Vital Statistics Database, they started accounting for things like smoking, pregnancy, workplace injury, everything else in 2014, collecting more information, and so there's going to be some consistency, or sometimes we use the term logical consistency that aligns for all that. The power and effectiveness of GIS, we can sort, query, we did some queries yesterday, summarize, meaning count the number of times something appears, because I can't average up Tuesday, Wednesday, Thursday, because they're nominal. There's nothing better about a Tuesday than a Wednesday, but I can count the number of times they appear. And so on nominal or categorical data, I can count the number of times something appears. So I can say, hey, the day of the week with the most homicides, or the zip code with the most gunshot wounds is this. And then we can also calculate statistics, which mean, median, mode, standard deviation, all that other good stuff here that we all know and love here. And so, like I said yesterday, when in doubt, right mouse click. I have a median age right here, right mouse click. I can sort ascending. We want to know what that means. Sort descending, custom sort, hide field. Because you notice when you open up that zip codes, I've got like hundreds of fields, probably about 150 fields right there. I don't want you to look at all of them. And so in other classes, I kind of make them, disable those. I can freeze or unfreeze. I can calculate the field. Hey, I want to calculate a new field. And so I create a new field, calculate it. I can calculate the geometry what's the radius, or not the radius, perimeter, area, centroid, or everything. Now, obviously for a point, I can't calculate the perimeter, but for a polygon, I can. And then summarize fields. I can open the field, or I can delete the field. Every once in a while, someone accidentally hits delete, and there goes the field, and sorry, it's gone, But I can run a graph. What's this graph called? It's called histogram. So this is a frequency. And so this is kind of like math class. We got a y-axis, we got an x-axis. So the x-axis in this case is the median age. The y-axis is the frequency or the count for these particular ArcGIS Pro. We use the word bins, and so 47.14 to 49 has whatever it is, 7 versus 12, and I bet if you were to add up all these frequencies, they would add up to be 100, because we're looking at counties. In addition, we've got the mean, the median, the standard deviation. What's the standard deviation measure?
deviation from the mean.
Deviation from the mean, how far it is from the mean. Even though I like medians as good measures of central tendency, but medians are a little bit more difficult to calculate. So how far? And so you have a team like, a football team that wins 8, 7, 8, 9, 9. They have the same mean as a team that might win 1 and then 13 and then 2 and then 15. Even though the averages are the same, they're going to have much different standard deviation. So standard deviation tells the variability or the volatility of the actual data themselves, the individual data, because these things are what we call global metrics. And in class, especially in geostats, we're going to talk about global metrics versus local metrics. So this describes the entire data set, and then local metrics describes, okay, Durham County has a z-score of negative 2.3. All right, that's really far below the mean, so that we can map that as well. Now, when we look at this GIS data in the form of tables, we've got records, fields, or attributes, and then where they meet is called a cell. And that's kind of using the taxonomy for that we use in Excel. But when we go and download data from the Greensboro Police Department, we go and I can hit the little button right here up in the top here and download all the crime incidents. So this is a nice HTML file that I can download this. I can save this HTML file and bring it in. So I can go to places like the Department of Public Safety and look at all the prison entrants for the year 2022 or current year by county. And I can map those. And so I can manage these fairly easily. In Excel, we can create and calculate new columns. And hopefully everyone here has some exposure to Excel. I've never taken an Excel class. What I do is just the stuff that I need to do. I've never taken an official Excel class. But we can do the same thing in ArcGIS. And so I have things like births, deaths, natural increase. And so we can look at this is information taken from the what is it called? The North Carolina State Demographer. And so we Google North Carolina State Demographer. There's tons and tons of data sitting up there about births, deaths, natural increase, net migration, everything else. So in Alamance County, they only gained 1,900 people between 2010 and 2020. Migration was 17,600 people. Wow. And so when you take some of Dr. McGinn's classes, the total number of people on the earth is, going up, but the only way you can get here or get to a country is you either born, you die, you move in, you move out. Those are the only 4 options you got. You're not like going to space or, no one moving the moon or anything like that. And so these things I think are really neat to see where natural increase is happening, especially when we talk about things like brain drain, push factors, pull factors that I think Dr. McGinn can speak to a little bit better, where like Brunswick County, they actually lost people due to natural increase. In Brunswick County, more people died than were born in Brunswick County. Down at Wilmington, where do they get all their people? People are moving there. This is really neat. I find an interest in this stuff here, and I think there's a lot of potential that kind of blends your Geography 1000, your world regional with, data-driven analysis. And what does that do to housing prices and crime rates and all the other things that are, impact our lives and our pocketbooks. But I can go and calculate these. So I can calculate percent growth, 100 times C2 minus B2 divided by B2, because when we calculate percent change, it is new minus old divided by old. Make sure, we got to remember, consider our Aunt Sally right there. Please excuse my dear Aunt Sally with the parentheses right there. You would not believe how many like weird numbers I get here. But you can have like 100% population change or 200% population change. It would double or triple. It's typically not possible. And you can also have like negative population change as well as if the population goes down. So think of numbers that make sense and don't make sense. We got people coming here from surveying and other more STEM fields that we know what a good number looks like. So I think some of those are up to you there. So now we can look at percent growth. So now we can see Alamance County grew by almost 13%. Anson County went down by 11%. Bertie County went down by 11%. Cabarrus County went up by 21% between 2010 and 2020. And I bet you if you were to make a map of this, I would bet you see spatial relationships with these. Now, there's lots of non-spatial data out there. The one thing when we want to map non-spatial data is we need something that has location, an address. If you have an address, can you figure out where it is on a map? Have you ever done that before in your life? We do it every day. It's called geocoding. Okay, costs a lot of money in ArcGIS Pro to do geocoding, these days. So if you can make your own geocoder and make it talk to ArcGIS Pro and make it work better than the NC1 map geocoder, which is like 50% accurate, like you got yourself a master's thesis right there, ready to go. Right there, ready to go. So we can get data from the census. Me and Baron a couple of weeks ago, we were downloading all the census data for Charlotte. Where we're going to get it, the 2000, 2010, 2020. We had to make sure it was consistent too. We had to get median household income because they have lots of different incomes. They have average income. They've got median, it's not household, what's the other? Family income, because households and families are two different things. And so we had to make sure we got median household income for 2010 versus 2000 versus 2020. Other information that we get, Department for Health Statistics, and then Department of Public Safety, where I can go through this ASQ, I'm not sure what it stands for, but I can click on a list, or not a list, but information for all prison entrants in the last year. And we can break those down by age, race, and then obviously county, so that something that like that can be mapped. But we need something that implies location, lat, long, northing, easting, whatever here. So when we look at these tables right here, I've got a county right here, and now I'm looking at all different types of cancer rates that we can map. Like just mapping something like this, bringing this into GIS from PDF. This is a master's thesis right here. This is a master's thesis right here, ready to go. When we zoom in on these, we can see colon, rectum cancer, or whatever else that we've got right there. You notice here, these rates, sometimes we have little stars because it gets into some of these small number of problems right here. So we don't want to calculate rates because a lot of times if we were to map, say, the infant mortality rate for Jackson County out in western North Carolina, and one African-American person had an infant mortality rate, what's that going to do to the rate? Skyrocket up because not a lot of African Americans live out there, or American Indian in, a county not outside of southeastern North Carolina. And so a lot of times they'll temper these rates right here because you don't want to see like a 123 because someone like me looking at that, oh my gosh, look at this. Well, it's just one, If something goes from 1 to 2, that's a 100% increase. I'm probably not as worried about that as if something goes from 75 to 150. And so the good thing about these data is everyone has access to it. The bad thing about it is that everyone has access to it. And so when we do the tabular field types here, there's different tabular fields here. Yep.
I'm sorry. I remember yesterday when we talked about how when we have data from the previous slide, how that potentially can go manipulate our tables and our graph and everything. So we get our data, we can potentially skew. That goes into factor as well.
Yeah.
When we have one person, like you said, we have one person there, we can manipulate the graph and try this. Oh, this is that.
Yes.
Instead of public
Yes.
And one of the things you start to realize when you're doing research, and again, I realize this in my dissertation, I'm sure Tim did too, that nobody's checking it. They're taking your word on it unless somebody really digs into it. So for instance, I did voting rate stuff and I had outliers with Native American instances. But when I took out Robeson County where the Lumbee Indians were, then they gave me more realistic responses. The thing was that nobody would have known that, and I could have published it with the outliers, and nobody would have known the difference if you didn't know North Carolina and all that stuff. So if you see the book, there's lies, damn lies, and statistics, right? That's the idea, is that you can lie with any statistic. It comes back on you for standing by your work that it's legitimate, or you just identify those outliers or identify those causes. You can write about it and make the maps about it, but identify, hey, this is the one African American case in this county that causes the high rate and all that stuff. So,
Yeah. And we're into that where we had Alondra, what's her name? I forget what her name is. Elena, PhD student, where we were looking at African American, female African American breast cancer deaths. She was a PhD student, and we had this zip code that had like 50 people in it, and it had like 3 deaths. And so that skyrocketed the rate, where the rates were like between 10 and 50, and this one had like 250. So what'd that do to the mean? Popped up the mean and then screwed up all of my geostatistics, because my geostatistics are based on the mean. It's going to screw up your clustering and everything since it's based on the mean, and you have something that's 5 times above the value. So we got rid of that. And also, when you get a committee, people are going to have different specialties. So whenever I'm on a committee, my big thing is, where'd you get the data? What'd you do to it? How reliable is it? What's the time period for it? And then I won't ask anything else.
when you do a lot of this stuff, Tim probably talks about in geostatistics, we both in our dissertations had you do statistic diagnostics with heteroscedasticity and all this stuff. And that section was to prove where the outliers were, how good the data was, and all that stuff. And I had one committee member like Tim mentioned that all he was a stats guy, right? That's all he cared about, was checking that stuff out. So he probably didn't even care about what the results of my dissertation was, just that the stats played out. So
yeah, over here, skewness and kurtosis.
there you go.
So tells you how stretched out it is, and I forget. Oh, skewness tells it like what side it's skewed in. Because in theory, you want data that looks like that if it's normalized. But I'm gonna kind of hustle through a couple of these other things, because when we make data, basically you need to just be you want to make sure we've got the correct precision here. So this is my house up there in Greensboro. Information about it. We've got dates. We've got short integers. We've got long integers. We've got blobs, binary large form, binary large, or floating points would require decimal points. And so if you're storing something like acreage, you don't want to store it as an integer, because it's just going to round it up or round it down. Or bedrooms, well, you're not going to have 3.2 bedrooms. You just, we care about this more. And why do we care about this stuff here? Because back in the day, I used to have an 8 gig computer. I lose 8 gig hard drives just in the dryer. I find them laying around my car. And so this is the space, the number of ones and zeros. The biggest concern is, and people run into, is that they just click next when they create a new field, and that first field is a short. And so when you're calculating GPA or percent, infant mortality rates, and you see it just truncated to the nearest number, because you're doing with the computer, the computer's doing what you tell it to. Hey, it's stored as a short. So we can calculate new columns. I've got some things on that as well. And so something like this is sex ratio. So the percentage or the number of males for every 100 females. That's right? Yeah. So number of males. So you can see there's a lot more females here, a lot more males here and here. Why are there so many males right here in Onslow County? Military base, exactly.
Skews it up.
Yep. And so you can see, and these are spatial in nature. You would think something like sex ratio is not, it is. I don't know why we got the human geographer to tell us. Also, tabular data too. We can join data. I find something cool on the internet, I can join it using a key. Now here, what is your key on campus? How are you identified? It's not Andy Agogo Stanley. What is it? A2O. A2O. You forget that, you're done, because the parking people and your bill and your registrar, you're in separate systems for them, but the unifying thing is the A2O number. So when you look at like the Guilford County parcel search, you're given a PIN. So this lady that we sold our house to, she's long gone, but this PIN is always going to be permanent. And that's going to be important. And so we can look it up by the PIN, and then that's going to be attached to everything, whether it's our plat, our sales, all that other stuff. So we need something that is going to be able to be joined to it. And down here, I've got a link, and I also have it in modules. These are just links to standalone tables that we have sitting there of stuff we've downloaded. Some of the stuff we've downloaded for, let's look at all the, libertarian voters in Alamance County. You can download that table and map it. Some of these are really simple. Some of these are really robust. In data science class, we were working with like 120,000 records, but my big thing about ArcGIS Pro is that it can consume, 3-4 million records, and it's not going to kick you out like Excel does. Okay. And so we work with 7 million voting records in, ArcGIS Pro. It's not going to like it, but it's going to do it. And where that Excel is going to kind of crap out on you. And so if I find a cool table right here, now this is my standalone table because I can see it ends with a CSV. I can also see it doesn't have an object ID. Though these are the little tricks that I've learned over the years, where that here, this is my attribute table for NC counties. It's got an object ID right here, which is typically just randomly assigned, but here it's in alphabetical order. And I can also see it doesn't have a postscript or identifier or extension right there. And so the main thing that I want to do is I want to map these data, and I just want to add this to the end of this. So when I go to symbology, instead of mapping POP 2010, POP 2013, I want to map July 2010 or July 2015. And these are data taken from the North Carolina State Demographer. You notice here there's 102 records, probably because when I downloaded, it had a couple extra records down at the bottom, or had something up at the top, but it's not going to match up. And so now I can map Anson County. And this is what we call a join. And this is kind of getting a little bit more into not advanced GIS data, but some of the more advanced functions that we get into above and beyond making maps and running queries. And this is kind of where you start to earn your big bucks in GIS, where how do you turn tabular data into spatial data? And these joins are it, because a lot of this is trial and error, because the state demographer might type in BURK space enter, and BURK space enter is different than BURK. And so these computers are just stupid, for lack of a better term. And so now I can map the latest and greatest data taken from the state demographer here. This is kind of my running joke. Florida doesn't equal this, this is an outdated reference, Florida. Yeah, but they're all spelled the same, but they look different. One's got a space, one's capitalized, or whatever. We can run statistics. This is my big thing here. And so we've got the skewness and kurtosis, all this kind, and then these things that you'll know those soon if you don't by now. But these are average household sizes. Other things we can do, we can run a summarize. So now we're looking at crime data, day of the week. We can't average up Tuesday, Wednesday, Thursday, Monday, whatever, but we can summarize those. So now we can make a table of which day of the week is most frequent for a particular set of data. That's what we did in data science class for gunshot wounds. We went and extracted out all the gunshot deaths. We counted them by zip code, and I just had a big table of zip codes. So it said 27707, 15, 27745, 23. And then I just joined that frequency map to an existing zip code and took that extra step right there. And this is what we did for this poster over here. We had a student who came from social work who, their friend lost a child due to SIDS. And so we extracted out all the SIDS deaths based on a certain code right here. Because when you die, you basically get assigned a code of what you died of. And then we had an age, and then we looked at statuses and birth counties, and then we looked at sex and race. And we saw this before, that it was much, much higher for males. And so now we can extract out the race right here. And so race here is not really significant between white, Black, non-Hispanic, and American Indian, Chinese, but a lot more males than females. Why is that? Why would male? I don't know why either. You know, I think at the end of the day, I think women are tougher. You know, they go and have kids and all this stuff.
Rabbit hole, potentially.
Yeah. You know, even at birth, women are tougher, and women, and later, men do dumb things to eliminate themselves. But even with these, these are statistically different. We're looking at 418 versus, there's like more than 100 more males than females that are, have SIDS deaths. But here, and I think we did this a little in data science class, we go to the documentation related to the vital statistics database, and it tells you what all these columns mean. What a 1, 2, 3, 4, 5. It gets ugly quickly, because at some point in time, guess what? You're going to be the person doing this. You're going to be the one, what's a 1, what's a 2, what's a 3? You're going to be hired by City of Oxford, and they're going to say, hey, what's condition 1 mean? Condition 2, what are all the different conditions for the telephone poles that you're collecting using your phone? You make that up. And to me, I think that's neat. That's really neat. But we joined the SIDS deaths, and now we made a map of all the SIDS deaths. I think the highest one here was down here in High Point here. There was another one out here. I think this is Rocky Mount. No, that's not Rocky Mount here. But you can see where there's more SIDS deaths. Now, we probably normalize these by population, look at these here. But this was over, 4 or 5 year period right here. Some of these are spatial, what are, one thing about SIDS, it's so capricious. To me, it's kind of like ALS, Lou Gehrig's disease. It's not really, there's not an income or a race or whatever that attacks it. It's just male, female. So a couple other things that we've got here. The Climate Prediction Center. This is one that we've worked with in past. In Geostats, we're going to work with it because we do interpolation routines with this. And this is kind of right here for research where we can go and download what is the high temperature, low temperature, snowfall. One time we downloaded the snowfall and looked at it, and it was like there was some place in Washington that had like 120 inches of snow sitting there. It's pretty neat. It was right at the base of like Mount Rainier. But we have a latitude, longitude, a temperature. This is an identifier, state, the name, and then a couple of other things right here. But if I have a latitude and a longitude, can you tell me where the location is? Of course, it's got a unique location. It's got only 2-digit precision. So how close are we really getting with 2-digit precision? Are we getting the exact thing? No. No, you tell me how close are we? This gets, how far is a degree? I'm really getting like
1 second is 30 meters.
1 second, 30 meters.
Yeah, and 1
1 degree is about 70 miles. So a 1/10 of a degree is about 7 miles. 100th of a degree is about 0.7 miles. So about 0.7 miles, about from here down to, Alston Street or so. Good. Yeah, when we're doing climate stuff, is our temperature really going to change between here and Alston Street? No. So a lot of times when you work with some of the NOAA, the climate stuff, what's the resolution of the climate data? Don't they have data, or back in the day they had data at like 3-kilometer resolution? No one's nodding their head, so I might be wrong. So about 2 miles, because your temperature, your climate or whatever isn't gonna change too much there. I don't need like high res temperature data because it doesn't necessarily change that much. Okay. Add X, Y, the one thing about it, we have X, we have Y, the one kind of misnomer about it, I say latitude, longitude, but really longitude is your X, latitude is your Y, even though we say it the other way. And the other thing is that in our coordinate system right here, we have to tell it what those units represent, because this computer is stupid. You know, it doesn't know any better. So we have to tell it, hey, these things are in degrees. So we have something called GCS WGS, Geodetic Coordinate System, World Geodetic Survey for 1984, because we've got one from 1927, we've got one from 1866, and actually the size and the shape of the Earth were different between 1984, 1927, and 1866. Not because the Earth actually physically changed. You know, we do have like sea level change and erosion and catastrophic events, but because our way of measuring these has gotten a little bit, not a little bit, a lot bit better. And so that 1 degree is really 1 degree in 1866 is slightly different than 1 degree and now. And that actually is creating a new data for like 2023, 2024, where that the center of the Earth is kind of moved about 6 feet. Because we've never dug down to the center of the Earth, you know. The furthest we've gotten is, you know, I don't know, 6 miles or something like that. Other things, Durham Police Department back in the day, they would supply us data like this, X and Y. Like X and Y right here. Are these in degrees? What units are these? What? How do I, first of all, how do I know it's not degrees?
The whole numbers are.
No, hold on. What is degrees? They go from latitude go from -90 to +90. What do longitudes go from? 0 to 360. -180 to +180. So they encompass 360 degrees of circle. So these aren't them. They basically what we do here, and I think I talked about this in data science and other classes, where this is the North Carolina state plane, where we stick some 0 point down in Alabama, and then everything in North Carolina is in the first quadrant. So everything's positive. Because in reality, in North Carolina, we're actually in the second quadrant according to the geographic coordinate system, because we have a negative longitude, positive latitude. Yep. So it's negative, positive. And so these are all the nasty numbers so that we can minimize. And basically the reason why we do that is so that we minimize distortion for the state of North Carolina, because North Carolina, it's got undulations, it's got topography, but it's also on a 3D surface. And so whenever you put a 3D surface onto a flat surface, like you wrap a Christmas present or wrap up a birthday present, what do you always have left over at the end? Extra paper. What do you do with the paper? Snip, snip, snip. Yeah. And you move on with your life. You can't snip, 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 stay in North Carolina. You know, so there's going to be some distortion no matter what, you know. And so I like, there's some neat kind of things up here where that you see the state of North Carolina back there. You notice the top edge is curved. Is it curved in real life? No. Why is it curved there? That's that distortion. So east and west really isn't left and right. It's along this curvature. So we've kind of tweaked the direction. I look at a map, up, north, down, south, left, east. Here, it's not really. It's kind of right along that curve right there. You know, because that's the distortion that North Carolina State Plane basically accepts or takes on when we do that. Now, when we add this XY, there we go, add it on. Now I know that this is correct because when I have my base map, it superimposes all the crimes on Durham. You know, because a lot of times if you switch like the X and Y, you'll see like all your crimes are in the Atlantic Ocean. All right, I did it wrong. And the good thing about ArcGIS Pro and all of you joining us online here is that it's got a base map. When you open up a map, it's got a base map ready to go right there. previous version of ArcGIS Pro that I used for 20 years didn't have that. So I had to like bring in some satellite imagery or add a base map, which took another click or two, add a base map, and then, all right, make sure it lines up. Because if it didn't line up, all right, you're using the wrong projection because there's hundreds of projections out there. We've got North Carolina State Plain. We've got like 5 different Texases. We've probably got 7 or 8 different Alaskas because Alaska gets really ugly because it's close to the North Pole. And so you're really going to have the difference in latitudes and longitudes are going to change because 1 degree of latitude is about 70 miles. 1 degree of longitude isn't 70 miles. It's going to get smaller and smaller and smaller as you go towards the equator. And that study is what we call geodesy. I'm sure you've heard that term, Andy, geodesy, study of the size and the shape of the earth, not only in surveying, but people like in GPS. GPS and drones do that because, what are things going on that change the size and the shape of the earth so that things line up and satellites talk to each other and all that other stuff. So that drone workshop I was at last week was pretty neat. We got geocoding. I think we know how to geocode right here. You type in an address. We have a geocoder because what we're going to do is we're going to open up the exercise and we're going to go through and do those. We're going to make some maps and then we'll kind of be on our way here. But we could do things like this. This is called networking. Okay, so there's a lot of network capabilities as well. And so I have a set of points. I want to figure out the closest distance to another set of points. And that's called networking. You do this all the time where I'm sitting here. I want to go to my kids' cross-country meet over here. What's the quickest way to get there? Because really, how many different ways are there for me to travel from Durham to my kids' cross-country meet?
Show me 2.
What's that?
Show me 2.
It's showing 2, but it could be like infinite, right? I could be like, all right, I'm going to drive down here and do this little loop-de-loop and go back this way and right, so think about the number of calculations that it does, but it knows that, hey, from the highway to the highway is quickest, and then from there, I'll calculate that route right there. And there's you want to go and study the algorithms to do this, man, you can make big bucks for working for school systems, because I believe a job just opened up for Guilford County Schools doing this. Hey, I've got these are the kindergartners coming in, next year. What are the best bus routes? You work for Google or not Google, Amazon. You don't want to take left turns, right? You want to take as many right turns as possible. Here's your list of packages. This is how you can get these done in 8 hours today. You just follow along. You developing those algorithms, I think, is really good. So we got geocoding. We'll talk about geocoding here, but this is what our geocoder looks like. We've got fields that match up with an address, a city, a region, postal, and then we have an output database or output feature class right here. So this is what we want to do. Because when we go to the Open Durham website, we just download the list of crimes as a table. They don't know anything about GIS. We know about GIS. And this is what we did in our crime map class. It does interpolation, other things, caveats about geocoding and all that other good stuff. So if we want, what we'll do is we'll open up exercise 2. We're going to make some maps out of it. We're going to talk about how we can make these. So those of you joining us later or online or don't have access to a computer, we can do this here. But we're going to go through the exercise and we'll just talk about the expectations for the next assignment and we should be good to go. All right, so we've got day 2 in-class exercise. We're going to go and download it. Make sure you unzip it and we're going to get something that looks like this. Okay, and I'll give everyone a couple of minutes to go through and do that. We're just downloading the exercise and,
Roll, that works. She was disappointed that there's, I said, no, have them online about Thursday,
oh, okay.
but that, it's gonna be in the conference room. so it
Okay.
won't look so bad.
Yeah, I'll be there. We got these three here. I already told them Thursday at 11 o'clock, conference room.
Be there, be square, there's food, there'll be food.
Oh, okay, that's the big thing. I got a food thing tomorrow too. Cool.
You got food tomorrow?
There's a health, I think I sent to everyone, the health disparity thing. I just wanna kind of go over and see some, Irene, she's nice, over at BBRI. I think Fred Hilton kind of was funding my.
So,
Yeah, they want us to get into health disparity stuff, so.
I said, let's gotta pick that up, so they got
Oh, cool.
and gone, so you good there.
Alright, so we got the float in here. Are you all set, Michael? Yes. Okay, cool. Pretty neat stuff. Andy's all set. Okay, so we're just gonna look at a couple things here. What I did was I created kind of a nice survey of the different ways that we can turn tabular data into GIS data. This is, like I said before, I get excited about this stuff because this is kind of my specialty. Sometimes we use the word data wrangling or spatial data wrangling, where we get data from multiple sources, and try to make some sense out of these here. And so once again, all this stuff probably looks familiar. We got the major cities, we got the zip codes, and I just created the county outlines here as kind of a reference right here. So we've got our 100 county outline, 100 counties right here. If I really want to, I can right mouse click and click on label. So I swear I can click label. And so you can actually see the names of the counties. Subdivisions of states are called counties here. And so we're over here in Durham County here. I live over here in Guilford County. So does Dr. McGinn. And so you can see these here. You notice some of these zip codes I don't have for the other data set. I'm not sure why. I think we took some of these out. But the voting data you can see is going to be the stuff that we were looking at yesterday. So it's got tons and tons of data that we've added with percent Republican, Democrat, unaffiliated, mail-in votes, anything and everything related to this here. Now, the one thing that I wanted to do was I've got some data sitting here that I went and downloaded. And so I can go to the black plus sign and add data. And there's lots of different places that I can do this. I can go to my downloads, I can sign in. You can see these are sitting here in databases if we wanted to, or I can go to my downloads right here and I can start adding these tables here. So DPT arrest, Erica Worksites, that's my wife. I guess these are all like Excel files and everything else that we can add here. I can add Gray. This is a picture of Gray, one of our students that I can add if I really wanted to our GIS. It's going to be useless. It's not going to be geo related because it doesn't know any better. But public schools, like here's a CSV of public schools. I can add this thing. So once I add it, I can right mouse click, open, and here's a table sitting here that I downloaded of public schools. And you can see what I've got. I've got an X, I got a Y. If I got an X and a Y, I can make a map out of this. I got a physical address. I got a city. I can map this. This is just some file that was sitting on my computer, ready to go. Kind of a funny example here is, so I've got all these different types of data that I can add. I can add PDFs or whatever else. I saw that word Gray, so I thought that was kind of funny there. Here's Gray. So I added Gray to my map. I don't know where I added them. Oh, maybe it doesn't like them. Oh, okay. Watch this. Zoom to layer. Why is he there? He showed up on my map. He's in the middle of the ocean. Why? Zoom to layer. Yeah, if I were to look at the properties of this thing right here, this is probably using state plane, source. You can see what it is, display. If I were to move my mouse around on these, you can see this is like zero, some sort of 0 point right here, according to my state plane. So these are just in pixels and I'm somehow converting him. So, all kidding aside. So we can add lots of stuff, garbage and non-garbage to our ArcGIS Pro. So I'm going to do zoom to layer. And so with me, if I want to, I can right mouse click, go to data, and I can export this table right to this database. So if I don't want to work with CSV files, which are independent of our ArcGIS Pro, I can import it into my database. So if I go to view catalog pane right here, and go to my database here, I can see I've got some tables right here, cities, states. So these things are tables, points, polygons, polygons, polygons. And so I can add, you can see what a database actually looks like. I can navigate to it through my through my black plus sign if I know where it is. But over here, I can go to my catalog pane. Now, previous incarnations of ArcGIS Pro or of ArcGIS, it was called Arc Catalog, which was a separate application so I can manage it. Now, this Arc Catalog, as it used to be called, is kind of integrated into ArcMap, so I can go and navigate everything here. I've got some sort of COVID map. I don't know why I add this to my project here, but I've got all this stuff right here. So I've got my maps and everything else. So this is through a little bit of management, because a lot of times people are going to have stuff in different places here, and I get real emotional about data management because I sometimes don't manage my data the best. And when you start seeing those red exclamation points, it's looking for something on it. You stored for a map on your computer referencing data stored on your flash drive, and the flash drive might be plugged in, but guess what? Your computer decided to call it E instead of F like it did the last time. The computer's not smart enough to figure those things out. And so we have these standalone tables. The other thing that I know it's a standalone table is that it says standalone table at the bottom. But if I were to right mouse click and look at properties, you would see that it's sitting in the database right here. It's sitting in this thing called GDB, Geodatabase. Okay? Geodatabase. When I worked with the military, they used to be stored in Microsoft Access databases, MDBs. And so now they've created proprietary databases called GDBs, which store these. Now, GDBs, they look all good and well here, but if I were to look at a GDB here, it's going to look really ugly. So if I were to go to my downloads and look at day 2, this is what my GDB looks like. So imagine if I tried clicking on any of these things, I'm not going to be able to open it up. So it'll only open up within the confines of ArcGIS Pro. And so you need to manage it within the confines of ArcGIS Pro. So if I were to go and delete one of these elements within the GDB, it would look bad. Really, really bad things would happen. And back in my younger days, I would magically corrupt databases and do weird things trying to be funny, or not funny, but cute or whatever, thinking I can edit some of these individual components of the Microsoft database when it was stored in Access, and bad things would happen. Now, the limitations with Access is that it's got a 2 gig limit. So that's why they kind of migrated this proprietary database. So I can bring in 4 million records, and it'll be able to consume and ingest them. Where that I had a 2 gig limit, and I'm working with lots of points and lots of polygons and lots of vertices. that 2 gig is going to go by really, really quickly. So that migration was good from an Esri standpoint. All right, so I've got some of these county growth. So if I right mouse click on county growth for 2020, this is the data we're looking at right here. Okay, I got an April estimate. I got a July estimate for 2010. I've got numeric, percent, births, deaths, natural increase, net migration. We want to map this stuff. I would love to. How do we map it? Right? And this is, I probably calculated this in ArcGIS Pro because I can calculate these in ArcGIS Pro. I can go to my little hamburger menu, click on fields, add new fields to this if I want. But this was the file that we were looking at before from the North Carolina State Demographer. So I want to look at the percent increase. And I can also look at like the natural increase, the net migration. There's lots of cool things here that I can map that tie into your world regional, your push factors, your pull factors, all that stuff that you cover in Dr. McGinn's class. You know, a lot of the qualitative stuff that we talk about in his class could be reinforced using this really simple data right here, which I think is neat. Now, who wants to map this stuff? Okay, I see Juan raising his hand. I see David raising his hand. I see Rosa raising her hand too. I'm just kidding there. But, all right, so I want to map this stuff here. And so let's forget about public schools for a minute because right now this is sitting here as a standalone table. It was previously a CSV file that I exported to the Geo database. I'm going to right mouse click, open attributes on counties, and here we are. Now, what I have here is I got a field here called name under counties. In the county growth, I have a field here called county. Now it's got 102 records, but I bet you if I were to go down, look at, I got a couple of like extra things right here that it's not going to be able to join or match to. So the first thing I'm going to do is what we call a tabular join. This is kind of where you start to earn your big bucks in GIS, being able to run a tabular join. Because what I want to do is add these attributes to the end of my counties. And so instead of mapping median age or average family size or POP 2013, I can go map this new stuff that I just derived. Okay, that's important. And so this is called the tabular join. Those of you joining us online, you might have to go back a couple of times to do this here. But under counties, we're going to right mouse click, and then we're going to go to joins and relates. Do you have that on your software, joins and relates? Okay, because when we go to the next thing, there, it's gonna like create table from data. We'll talk about those in a second there. But we're gonna do add join, okay? Because spatial join is something entirely different. And we're gonna go to add join, and I'm just gonna follow the directions. Okay, my input table is NC counties. My join field is going to be what? The one that was called name that has the names of the counties. And then the join table is going to be county growth with the field called county. So the field names don't necessarily need to be the same. Just for the heck of it, I'm going to click validate join. And let's just see what it says. All right, it says a 1-to-1 join has matched 102 records. The input table has 100 and the join table has 102. Well, what is the difference between that 100 and 102? What is accounting for that difference? Remember in that county growth, down at the bottom it said state and then like source? Because I just brought in the table. I didn't go and get rid of any extra stuff. And so is there a county called state? No. Okay, so it's going to say, I'm sorry, I can't find it. That's really good because a lot of times when you run these, you might get like 50 out of 700. And that gets really ugly because at some point in time, someone like typed in a zip code, typed in a space, and then typed in enter. You're not going to see that space in Excel or ArcGIS Pro, but ArcGIS Pro and Excel are going to understand that space. And so Burke with a space is different than Burke. And those are some of the challenges. Misspellings. If everything is capitalized versus lowercase, are you going to have to go and retype every single thing?
No, can you get it?
You can edit, or what can you do? In Excel, we can run a thing called upper or lower. So just like we can calculate columns, column A plus column B, hey, everything in column A that's called name, I just want to make it uppercase equals upper. And so there are a lot of string functions out there that I don't think as many people realize, because when we talk about functions, especially in geostats, we're adding columns, subtracting columns, deriving percentages from columns. That's what we're doing. But I can just as easily as, hey, make this thing in uppercase, because when you go to the Department of Public Safety, it makes everything uppercase. Okay? Good luck with going through and extracting everything. This is where I'm going to tell my magical story of where I got my part of my genius from. Was we had to do something with geocoding where we had to match up, and all of the addresses had to be in separate columns. And they provided us, this Army installation provided as like 23 Main Street, comma, Lafayette, comma, Louisiana, comma, 27325. And we hired these new people, a guy named Tim and another guy, what was his name? Mike. Tim and Mike. It's kind of funny because I'm Tim and I have a brother named Mike. But and so they spent like their first week of just cutting and pasting stuff in those individual columns. And what do you think they said? This is really boring. I didn't sign up for this. And what do you think I said? And I was driving and I was like, you know what? There's an easier way we can do this. What do you think the easy way was? Hey, in addition to making things upper and lowercase, what you can do is you can look for commas. So, hey, 23 Main Street, comma. Hey, everything to the left of that comma is going to be in one field. Now I got a new thing that we get rid of the comma. All right, anything to the left of that new field is going to be the state. Anything to the left of that new field, or the city, and then the state, and all that remaining left is the zip. And so we wrote, I don't think I might have done it in ArcGIS Pro or ArcMap at the time, but I know I definitely did it in Excel. And so you could write something called a macro, which is just in Visual Basic, right? This big old macro, it was probably like 15, 20 lines or so. And we just went boop, boop, boop. You took each thing and just, you could see it all populate these things and do that. Because I felt bad for these guys. I don't know why no one else thought of it. They were bored. They hated it. Because we didn't want these folks quitting like after a week. You know what I mean? That's the worst thing. When people leave after like a week or like a year or two, like you spend a lot of times training people. And you don't want people leaving. You don't want people, you got stuff that needs to be done, but you don't want people getting bored. Grad students, I can make you do all the boring stuff I want because you're not going to leave. You better not leave. And you're only doing it for what, 6 months a year or whatever, 6 months a year or whatever. I know. So, but those were some kind of interesting programming solutions. Now, there were some weird cases where it said, 23 Main Street, comma, apartment 23. All right, this is a weird one. It's got 5 fields. We'll go through and redo the things with the apartments later. But those are string operations that we can run. All right, sorry for the diatribe there. Sorry for the diatribe there. All right, so we got our join. Now, I'm going to just click OK. And it's going to do an add join. I don't see anything magic. I don't see any like exclamation points or it worked. This is the one thing about ArcGIS Pro is that it's very uninspiring with the results. So we got to figure out where these results show up, where that previous versions of ArcMap, they'd say, mission completed, process completed. You can go on about your life. Now, when I go to NC counties, let's look at it. All right, I got my state, my county, my POP 2010, but now what do I have here at the right here? All the way to the right, what do I have? I have an object ID. Now, this is the table. Look at the table sitting right there. So now if I were to highlight Allegheny County, look what I got. I got 2010, numeric, percent increase, births, deaths, natural increase. We can find all the counties in North Carolina where actually more people died in 2020 than 2010. That's an interesting dynamic. Because countries like Denmark and Italy and Sweden, they like more people die than are born there, but not as many people want to move to Sweden. So what's happening? Those populations are going down, and things like, dependency ratios and all those other things that Dr. McGinn talks about are really a pressing problem. Then they have immigration. And so what are some of the geopolitical and cultural issues attached to some of the immigration? All right, so we've attached these. Hey, let's go and map these. And so now I can right mouse click, go to symbology. Even to this day, I'm not a big fan of the mapping thing here, but under instead of single symbol, I'm going to map graduated colors. And if I want to, I don't want to map that. I'm sorry. I'm going to just uncheck counties. I want to map my counties because basically that was the one that I went through the trouble of creating. So right mouse click on counties, I'm sorry, and go to symbology. Instead of single symbol, we're going to go to graduated colors. And so here I got Pop 2010. That's pretty self-explanatory what that is. But I'm going to go down to these ones that we created now. Okay. So percent. So now this is where percent change. Okay, click on symbology here. I have field, I have normalization. If it's a percent, does it need to be normalized? No. Okay. Methods. I love quantile. Do you know why I love quantile? Because each color appears the same number of times. So typically when we look at these, and just for the heck of it, just since we're here and we're all together as friends, if I were to look at this percent right here, if I were to right mouse click and click on statistics, this is what it looks like here. This is what a distribution of percent looks like here. You can see the mean is 5.1, 3.45 standard deviation, all that skewness, kurtosis. Minimum was negative 14.5. So actually there was a county out there that had lost more than almost 15% of its population between 2010 and 2. And I have this thing here, I mentioned these before, but bins. So I can increase the number of bins. Okay. Me, I'm a good like 5 bin person, probably 10 bin person. So you can get an idea as to what it looks like. Pretty neat. This is just stuff this was stuff that was sitting at the North Carolina State Demographer, 20 minutes ago. And now we're doing real world stuff to this. Okay, so we can map those as well. Symbology, graduate, so we can map the percent. We can map, say, the numeric percent births. Now would I need to normalize births by population?
Yeah.
Yes, because counties with higher population will tend to have a higher number of births. So if I want to, I'll just normalize by April 2020. So now we can start to see the counties that are having the highest number of births. And the interesting thing about these, when you start to normalize these, they're all going to be spatially related. This is the thing that I find really neat. Let's normalize deaths. Why are there so few deaths out here in Watauga County or Onslow County? Military, right? So they're younger. What's in Watauga County? App State. So when I normalize the number of deaths, typically what ages of people tend to die at higher rates than others? older people. Right? You know, so when we map death rates, even like cancer, you know, diabetes, you're basically mapping where the old people live. And so we have something called age grading, which skews that out.
And then you also get into all the other phenomenon like brain drain, right? And in the northeast corridor of African American highly populated counties, those people migrate to urban areas and to HBCUs, so it leaves all the old people there, which then skews the percentages of death because you have brain drain and creative class moving out of old rural non-industrialized counties, right? If you look at that map, you see it's all along the population triad of where those young people live. So all that stuff can be inferred from a lot of these other demographic factors that Dr. Maroney is displaying. You can make a lot of inferences to what's going on culturally and in the human side of things.
Yeah, and this is what Dr. McGinn's just talking about. This is net migration. And so you can see all these areas in like yellowish right here. These are all the areas where people are leaving. So net migration. So they're leaving areas in yellow, go in the areas dark.
And again, who moves? Young people move, right? And old people tend to move when they retire, but then they die where they live. So they're not moving, you know, so you get these weird correlations or coincidences that occur with these data points.
Do I have another one here? Oh, natural increase. And then, you know, what ages of people are having kids? You know, middle-aged folks or young, yeah, young to middle age. So you can see where they are, even though you kind of got some areas down here in southeastern North Carolina, which are probably going to have higher than average birth rates. So we can make a map out of that. That's the first one we're looking at here. The next one here, I got DPD crime. I can right mouse click, open up the attribute table. So these are all of the crimes that we have right here. We have addresses. I don't think I want to geocode all 118,000 addresses. That would take a really long time. I'm going to sign into this here. Okay, but we could go through and query out certain. We can go and query out certain crimes if we want to here. So if we wanted to, we can query out, because a lot of times when you work with data, you're working with something like this: 118,000 crimes sitting in a database. All right, now it's up to you to figure out what you want to map, because like I said before, it would cost a lot of time, credits, money to do this. And so now we can extract out motor vehicle thefts, or we can extract out homicides. Do we know how to extract out data? Do we know how to query data? Of course we can. And so I can go to map, select by attributes, and I'll just select out the well, let's look for the homicides. So charge description is equal to, I think it's called murder and non-negligent homicide. Homicide, yes. Let's do the second one. Oh, you can pick out any one that you want here if we want. Because I don't know why there's two lost properties there. What I think is that there is going to be someone put a space in it, an extra space in it or something like that. All right. Let's look for an interesting one here.
Let's see, you know.
Gambling. Oh, that'd be pretty fun. Where's that? Gambling, betting and wagering. Okay. We got 4 of those. Okay. And promoting. All right. So how about charge description contains the text. How about we just type in the word gambling? How's that sound? And so we can run charge description contains the text gambling. So now we can run clears on these instead of doing greater than or less than, because the thing about ArcGIS Pro is that it's really smart in that it differentiates between numbers and text. So it knows the difference between those. So if you start storing your numbers in text, like your 820 numbers, which we can't or shouldn't be able to add, subtract, square root of, or whatever, we can do that. So charge description contains the word gambling. We're going to click apply. And so you can see we've got 5 crimes here, or 5 of them. All right, I can click on this. And what I want to do is I want to go, and you can see they're all at the same location. And all around the same date. All right, we better pick another one. 6900 Fayetteville Street. Charge description. You had a good choice there, Ahmed. What else do we want to look at? Larceny pickpocketing. All right, cool. Let's get all the pickpockets. Okay. All right. All right. Charge description is equal to larceny pickpocketing. We'll see where all the pickpocketing crimes were around the city. I'm going to click OK. And now under DPD crimes, and you can pick any crime that you want. I can see where they were right here. But what I'm going to do is right mouse click and go data export table, because I don't want to geocode all 118,000 of those. I just want to create its own standalone table. And so the output table is going to be here. And so the output table, it's going to be in my COVID map that I'm storing everything at. And I'm just going to call those pickpocket. And then we're gonna geocode this, and then we're gonna run another, and then I'm gonna just have us make some maps. So these are all my pickpocket crimes. Yeah. Right there. You don't need the input table. Change that. Change the name of that. Yeah. You got that one? The bottom. All right. Make sure you change the name of the bottom one to pickpocket crime, and that's it. Don't change the name of the database because the database name is already set. Yeah. Do the top one. No, that's fine. That's okay. You got 60 there. Stop that. Right mouse click. Then export that pickpocket. Data export. Data's down at the bottom. And then change the name of that. Click on that. And then just call it pickpocket. So we got this thing here called pickpocket. Let's make a map out of this. So we're going to right mouse click. And I'm going to click geocode table. If you're working with the newer versions of ArcGIS Pro, it is called this geocode table. Yeah, geocode table. If you're working with the newer versions of ArcGIS Pro, those of us joining us online, it's something like make data from tables or something like that. The output's a little bit different, but then we're just going to geocode the table based on what? The address right here. So we're going to click Start. I need to find my locator. Where is my locator? Oh, crud, where is it? Where's your locator? What is your locator? Where is it? Did we do this in data science class? I know we did this in our other class. This is the tricky part, okay? So we're gonna go to View, and those of us joining us online or joining us later, we're gonna go to View. Catalog Plane. And we're gonna click on Favorites right here. And when we look at favorites right here, we've got a lot of different things right here. Okay, I got this thing here called services.geocode.arcgis.com. Does anyone have that? So go to favorites. Go up to the top favorites. You got that? Okay, no one has it. Who wants it? Because you know what I'm gonna do? I'm right here. I'm gonna right mouse click and click on add to project. So it's gonna be there. But now the first thing we need to do is add it. Okay, I'm gonna click on my properties right here just to make sure we can add it. So my properties, we're gonna have to type this thing in right there. I'm gonna make it real big. All right, so under my pane, view, come on. We're gonna go add item. We're gonna go to server, ArcGIS server, and I'm gonna cut and paste this thing right in there. Here we go. I'm gonna make this real big here. Okay. So geocode, HTTPS, geocode.arcgis.com/arcgis/services. That's going to be the dedicated URL so we can connect to it. Now, the other thing that needs to happen is you need to be logged into your NCCU account while you're doing this, because it's going to say, hey, do you have the credits to go through and do this? Because if I didn't give Andy any credits, it's going to say, hey, Andy, you can't run this because I didn't give you the credits. We got a few million credits, which is a lot better than what we used to have. So everyone should be able to run it. But you only have to do this once. Only have to do this once. Because you notice when you look at my favorites, what do I have going on here? I got NCH, NHGov, I've got North Carolina One Map. This thing right here is actually a portal right here. So I've got bridges on NCDOT. So I'm connected to a few different of these kind of favorites right here. All right, so you connected, and now you'll see it in your favorites. You see it in your favorites? Right mouse click, add to project. I don't know why this is so hard, or it comes off as hard or whatever here, because lots of other organizations out there, instead of downloading their data, you can connect to their service. So you can click that black plus sign, connect to their service. The one thing about their service, like NC One Map, is that they might not let you export data, because I can set up the properties. Anyone can set up the properties, so it might not let you export the data or edit the data. So that's why I like to go and download shapefiles and feature classes on my own from those places if they allow it. All right, so now we can right mouse click, pickpocket crimes, geocode data, next. All right. All right, under servers, there it is. Uh-oh. Okay, and then there's the little house right there. This is World Geocoding Service. All right, so you're able to add it there? Input locator there. For servers. Double click on that. Right. On servers. Click on the thing. Double click on that. And then you see a little house pop up. You better see a little house pop up. All right, next. Pickpocket crimes. Do we have more than one field? Yes. Because these days it can truncate the commas that it didn't truncate like almost 20 years ago when I was working on that project. And so, yep, we do. All right, what are the fields here? The address is going to be called address 2. Address 2 is called none. Do we have a city, state? Nope. All it did was give us an address. So I don't know why they called it address 2 instead of address 1. What's that? Yep, next. Now, what I really should have done is I probably should have gone over here and said, put in a column called city, called Durham, but when we ran it before, there were actually Durham Police Department crimes that occurred in Morrisville and Bahama and Chapel Hill that were listed there and kind of gave us some problems. All right, next. Output is called pickpocket crimes geocoded. We're just going to go for the United States. Nah, forget about this stuff here. This says here, you're using up credits, which is code for money. And I'm going to run it. Now, this is only 60 of them. Not only, but. What's that?
What am I selecting?
You can pick none. I did none. I'll show you what happened with those. Yeah. Here's our 60. So. Did you add that geocoder?
Next one.
Okay, yeah, let's get that website up there going.
It's okay. That's all I was trying to notice that one thing necessarily.
Yeah.
I think this is.
You only do it, you only gotta do it once, so just type in this thing right there. And during, if I think of it during, announcement, in the announcements, I'll cut and paste those things in there. Also, if there's, I'll probably think of cutting and pasting some other services that I also use, URLs for these services. Because that really long one was our server. So instead of clicking on organization, there's a lot of ways that we can access our data sitting there as well. You know, so you can go to my organization, or you can go to this, you know, you can go this way as well. All right, you got it, Ahmed?
Yes.
All right. We'll let Ahmed catch up here. But when we run this, it says 9 match, 49 unmatched, 2 tied. No, we don't want to rematch because, but let's see what happens. When I run in, you know, when I zoom in to Durham, let's see what it looks like here. You can see all the pickpocket crimes here, but when you the funny thing is when you ran it, most of them are going to be out here, spread around. Why? Because we didn't specify the city. So how many different 4,200 university drives do you think are out there? Probably more than one. You know, even though the computer was smart enough to know that a lot of these are going to be concentrated in, a majority of these are going to be concentrated in the Durham area. It has them in other places as well. And so we didn't do, not we, you all, no, I didn't do a good job of specifying this, but this is the raw data that I went and downloaded from the crime website, you know, and when we download it from the Open Durham site, like it doesn't give you a city. It just says DPD data, even though we got to specify it because the computer geocoder isn't smart enough to know that it is, geocoder isn't smart enough to know that it's in Durham. Okay. Got this one. Very last one we're going to look at is, these are just the different ways that we can kind of look at data. Last one is, and we got public schools right there. We could have gone through and geocoded all the public high schools or whatever, you know, schools. Last one here is something we get from the Climate Prediction Center. This is maximum temperature as of 4/17/2021. And so you can see on April the 17th or April 17th, 2021, at this latitude and this longitude, this was the maximum temperature on that day in Alberta, in Alaska, and all these other places as well. Okay. Who wants to make a map out of that? I do. Cool. All right, so we're gonna right mouse click. This is what we call display XY data, because this was just sitting under something we downloaded off a website. So display XY data. What's the X? What's the Y? X is longitude. Y is latitude. Because remember, longitude measures east and west, left and right, or however we want to say it. The other thing here, under coordinate system, what does your coordinate system say, Ahmed?
GCS.
Okay, you're lucky. You know why? Because sometimes it might say state plane or whatever projection we're working with. This thing's probably smart enough to know, hey, these numbers are state plane, but we can click little world and we can click on all the different projections here. We've got different geographic projections. We have different projected projections or projected systems. Okay, so we got X, Y. There we go. Now look what we have here. Look at all these dots. Basically, we just went and mapped every single one of these points. All 5,670 of these points right here. With the max temperature of that day. Right mouse click. I can go to symbology. Watch what I can do here. I can make a nice little graduated symbol. Based on the amount. Look at. Can you see where the higher areas are or the lower? Where was it cold? It was cold in the Midwest, cold in the Northeast. Look at this. This is pretty cool. These are just some graduated symbols showing the temperatures at all these sites. Now, what we do in my class is we create a surface map for this here so I can figure out where it is here, or here, or here, or wherever. So we create a surface map, a raster map, using interpolation, extrapolation routines to do this. And so we have things called like Kriging and splining and IDW and all these other things. Andy's nodding his head. He knows what we're talking about here to fill in the missing pieces there. And those are interpolation, extrapolation, filling in the missing pieces. When you look at a weather map in the morning and it tells you, and I ask Alexa, what is the temperature where I am? Does it really know where the temperature where I am is? No. It's probably from the station, but probably from the station or the airport it's reporting for, and it just kind of fills in the rest of the stuff based on the known values. That's all it does. We had a student do a project on this. So we could do interpolation, extrapolation. We can make maps on this stuff here. There's a whole thesis sitting right here, that you can work on with this, time series stuff. One of the students, what they wanted to look at was the daily temperature change throughout a couple of months. So they had the max minus the min. That'd be really easy to automate. No, it would be really easy for one of you to automate in Python. It wouldn't be easy for me because I wouldn't want to do it. But they brought it in. And in data science class, remember, we were bringing in files, changing file names, all that other good stuff. Like we were able to do some really neat stuff. If we named it correctly, we could just loop through, bring in these files, interpolate, extrapolate. We could do some really neat things in Python and Model Builder with those. All right, so assignment that we're going to have for today is you're going to go and make a map, because these things, they're not really maps, they're just graphics. So what you're going to do is make an actual map. And I know Ahmed knows how to do it because he had to make a whole bunch of maps, or we use the term layouts, okay, where you put a north arrow and a south arrow and a title and all that pretty stuff that people still want to look at. People my age want to look at. People your age don't want it. You all want to just look at the little phone and do this. But other considerations about things like colors. And so to me, I think the art and science of cartography is really, this is where it separates kind of the you know, the good map people from the not so good map people. And so some of the considerations about colors and fonts and consistency and what we call visual hierarchy, you know, things that are big at the top are most important. Type of colors, color grays. We go from light green to dark green, light purple to dark purple. Why do I have greens and purples on those maps? What's so special about green and purple?
They're show positive, happy.
Show growth. Why don't I use reds and oranges?
And they show that stuff pretty much.
No, also, there's not as much internal contrast from light orange to dark orange or light red to dark red, but there's more I can tell the difference between the second and third purple or green better than I can tell the difference between the second and third orange or red. So those are things where we hit up the people across campus in psychology or wherever else to what's the best colors people can understand. Now, most of the time we go from gray to black because if you're colorblind, you're not going to know the difference either way, you know, especially the particular colors, you know, that we may or may not even realize. And so we're going to make a nice layout, a nice pretty map that you can insert into a paper, a poster or something like that, because there is still some value where we can export these as PDFs and tips and everything else. Okay. I'm about done here. So for next week, and you can work on it now, make a map of just something that we did. Maybe you can do the the percent change. Go to that Google map, to Google Drive if you want to, and just download some cool data that you like that I've posted up there. Anything else that I'm missing, Dr. McGinn?
Nope, I don't think so. Like I said, we talked a little bit about that color theory stuff the other day, but no, I think you got it all.
Okay, cool. All right, and we'll meet back here tomorrow. Hopefully it's not going to rain or anything like that, but we're going to be flying drones tomorrow, flying drones and getting in the weeds with some of these things and relying on Ahmed for some of this because he did a lot of this. But
Wednesday's perfect. because
I
Thursday-
think tomorrow looks pretty good. 91 degrees tomorrow
I
afternoon.
might have to bring on my shorts and show off my chicken legs here. So, and then we'll also install DJI Go, but we'll also use this. We'll also use this, but we'll have the Mavic and some other things ready to go. So I'll see you all tomorrow and I'll be here. I got a meeting at 2 o'clock. I got graduate council at 2, so I have to be here. I'd rather not, but. All right, and I'll turn this off. All set, David?
I think so. Think all good. Yep.
All right, cool. All right, we're just revisiting making some of those maps that you made back in 34, 35. So the maps and the colors and all that other good stuff. So, all right, enjoy the rest of Florida.
Okay. Thanks a lot. Yeah. I'll try to join online tomorrow, but I'll miss
Okay.
Thursday and Friday, but I'll try to get caught up over the weekend.
That sounds good. And we'll post the images that we collect tomorrow to a shared drive. And so you can do the drone to map processing with all those as well.
Okay. Great. Thanks a
All right,
lot.
sounds good. All right, see you later. Have fun.
Bye. Thanks.